My name is Ryan Ingebritsen. I'm here today to talk to you about kinesthetic empathy in remote and interactive performance. First of all, we have to define what kinesthetic empathy is. Kinesthetic interaction design, it means the ability to detect and decode the input of other users, vicarious performance in music, or metakinesis or intermimicry in dance. Talks about the phenomenon of feeling a performance as you're watching it in your body. Playing and breathing together in live performance can also be seen as a type of kinesthetic empathy. Research done by Alexander Demos et al. In Entrainment in musical performance suggests that when two musicians play the same music together, there's a correlation between the postural sway that is far greater than chance. And the same is true for performer and observer. When an observer feels that the musical performance is expressive, there's a higher correlation between the postural sway of the performer and the observer. This seems to give experimental evidence for the existence of kinesthetic empathy in performance situations. On remote platforms, this ability to feel one another is somewhat blocked. Though the slight time lag on remote platforms is generally blamed for the inability to play music online together, even in situations where time delay can be eradicated, other missing elements also contribute to the inability to feel the experience of making music, such as peripheral vision, spatial localization of sound, and even very expensive experiments that attempt to emulate all of these conditions have not reproduced a fully live feeling. And further, these systems are inaccessible to the typical musician. Networked performance that facilitates modes of performance native to the system itself have been with us for some time. It has been shown how in such networked performances, performers can achieve kinesthetic empathy according to the definitions in kinesthetic interaction design. We feel that because the kind of kinesthetic empathy is facilitated through technological mediation and not necessarily physical presence, this could translate to the remote environment. So a few examples. First, SENTIENT object is a multi-user remote performance system for up to 8 players where data controlling pitch, panning, tempo, and duration of notes in a randomized tone generator is sent over the web. Then sound is generated locally so that only small packets of control data are sent and received, minimizing latency. The design of the control system makes it fairly intuitive, and the indirect nature of the interaction renders any residual latency kind of unnoticeable. Performers are encouraged to try to differentiate themselves from other players at first until they understand the relationship between their own sound and those of others, and then trying to explore various expressive combinations. Most players felt like they were interacting with one another in a way that felt responsive, and one performer said it was like playing music with others for the first time since the pandemic started. Another example, Layered Sound, is a live painting performance created by myself and painter Melanie Brown. For this, we leverage an existing performance system in which her canvas is amplified and its sound is used to generate a number of sonic responses. Remote performance was achieved by using the LISTENTO plugin to receive and send high-quality sound between performers. The online format was almost an advantage as it created a completely immersive sonic environment, emphasizing the connection between the brushstrokes and the sonic reactions. And finally, in the summer of 2020, the Fresh Ink New Music Festival in Chicago encouraged composers to leverage the pandemic situation to create works specifically for an online environment that did not require precise time synchronization. The most successful cases involved some explicit compositional instruction to focus on a specific aspect of a listening to facilitate connection between performers. An example of this is the piece Colorful Clouds by Spencer Arias. Colorful Clouds used a video of clouds subtly shifting in color while a pre-recorded electronic part played. Performers were instructed to pay attention to the electronic score, the shifting color, and the density of the clouds, and react to each other based on deep listening to the others playing. Now, in thinking about how kinesthetic empathy is achieved, we realized that there were certain prerequisites we had not really considered. When learning an instrument, we train our body to react automatically. Just like driving a car, this knowledge lies in what is often referred to as the body schema. Though playing different instruments, members of an ensemble are familiar with various conventions, notation, and theoretical systems of their musical cultures as a kind of interactive system, and through this system they can achieve kinesthetic empathy. Though we have the term kinesthetic empathy to describe the connection between two or more human beings, we have no common term for the consistent mapping between our auditory and sensory motor system that allows us to play instruments. We propose the term auditory kinesthesia to describe this phenomenon and suggest that it is a prerequisite for kinesthetic empathy. In our 3 examples, a sentient object achieved auditory kinesthesia through a clear and easy-to-use graphic user interface. Layered sound takes advantage of an existing auditory kinesthesia and leverages that to create this kinesthetic empathy remotely. And Colorful Clouds leverages the musician's existing auditory kinesthesia with their instruments, but replaces the interactive system of traditional notated music with a system that focuses performers' attention on deeply listening to one another. All of these situations were done in the context of live performance in real-world situations. So for us, the next step of this research is to put this in a more controlled environment, and for this, we propose using another system, the Body Sample Player. The Body Sample Player is a system designed for previous work and has had a long performance history with several pieces performed multiple times by skilled performers. We propose using the experiments of Alexander Demos as a model for our investigations to explore the correlations in perceived expressivity and correlations of movement between performances and observers. If there's a difference in perceived expressivity with experienced users versus users with no first-hand experience of the system. And if the certain training strategies develop a greater sense of oral kinesthesia and more expressive performances. By this, we hope to further reinforce the observations made in these examples, and that further studies in the fields of cognitive and neuropsychology will continue to inform our work as well. Thanks for listening, and let's just open it up to questions.